Hi guys. So I stumbled on a particular video on TikTok. In fact, it has started trending, and I was just like, let me shed light on this. So let's watch this video together, guys.
Say the light too low. I beg. Do you have experience of this thing? Because I don't understand. My electrician there say it's not possible. Give us breakdown why it's not possible. Let us know, please. Tell us. I beg.
The solar guy said that the current is too low. That this 10 kVA inverter cannot charge this Felicity battery. That the current is too low. And the current we are having here now is 180 to 190. And I say, okay, you said the current is too low. Okay, let's add the inverter to the stabilizer. We'll have a 5,000 watt stabilizer here, so that it can be able to power it to reach 200. He still said that even if we add the stabilizer, it cannot still charge the battery. That is why I'm confused. At least we have 200. You know, the normal current we use is 220. Based on Nigeria, you cannot be able to get 220 unless on the feeder pillar. The lowest amount you can get is for 210, 250, or 200, depending on how closer to the transformer. But now that we are far away from the transformer, we are able to get 180. Then we use stabilizer, we can get 200. He said he cannot be able to charge the battery. So that is why I'm confused on. So I don't know if anybody have an idea.
And this is the stabilizer.
And this is the 5,000 watt stabilizer. So if you add this 5,000 watt stabilizer, we are able to get 200.
Maybe it doesn't know how to do the connection. Can you do the connection?
That is 200 voltage to charge this thing. He said that he cannot still charge it. That is why I'm confused.
I feel that it doesn't know the connection, how to do it. Can you do it?
So I believe you watched the video. Now, let me start from this. A lot is a lot is wrong with that installation. A lot is wrong, and I would say with professional jobs, please make sure a professional with experience handles it. Now, if you watch that video very well, I think a lot is wrong, but first and foremost, people are just funny. Most especially customers, clients, they are very, very, very funny. Now, the reason why I would say they are funny is you gave a job to a solar technician or installer now to do for you. The job had an issue, one or two issues, and then you now called on electrician to come and checkmate what a solar installer did. These two things, I don't know. In this space, I've discovered with my own years of experience, I've discovered that people are now taking each both for each. A solar installer is not an electrician, no. And an electrician is not a solar installer. Though there are some electricians that if they have the technical know-how or they have a training, let me put it that way. If they have a training on solar, they can do it. There are guys that are electricians that I personally have trained on solar installations. In fact, inverter repairs. Sure, you get, they're hard dead and do it very well. So if the particular electrician has technical know-how, has basic knowledge as regards solar installations and all, is fine. But you having this mentality or thinking that any electrician that you find out there has knowledge on solar is a zero for me. Because I've come across some installations that I've corrected, and then I now found out that when you now start asking them, it was like it was an electrician that did it for us in the long run. Now still we technician will come correct them. So these people might understand what it takes when it comes to electrical wiring and all. But you see, solar is entirely different. But because in solar, we are dealing with two sections of connections. We are dealing with AC connections, and then we are dealing with DC connections. So these are two different sections of connections. So it takes someone that understands this space and is professional, and then is has the technical know-how. In fact, must even understand some theoretical basis, because it's just obvious from this video that this particular electrician does not even understand anything that has to do with power. Let me put it that way, power. Let me use the word power. Now, what is power? To we physicists or electrical student or guys now, power is the rate of currents and voltage flowing. So like in terms of what is it called? In terms of if I want to term it in terms of a formula now, power is just voltage times current. So which means two factors determines power: the voltage of the current flowing. We have current flowing. We have a conductor now, for example. Current flows through a conductor. Now this current that flows through a conductor, how do we quantify this current? It is in terms of voltage. It is in terms of voltage. So now voltage multiplied by current equals power. So now you referring to you and these two particular quantity, we call them quantity in physics, and this particular quantity, which is voltage, is measured in voltage is measured in volt, and current is current is measured in amps. So you now, according to that video, is saying the current is low. The solar installer said the current is low. The current is low. Instead of you to say the voltage is low, you are referring to voltage as current. That thing is very, very common in Nigeria. It's very, 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 very common in Nigeria. You see all these guys, they don't understand this thing. So they are just mixing it. And then they are now transferring this knowledge to people that does not even understand it too, and they emulate it and start spreading it up and down. So you are referring to voltage and you are calling it as current. There is difference between current and voltage. The energy flowing through a conductor, the amount of that current flowing, the amount is measured in voltage. But if you want to measure current, as a current is measured in amps, and current is what determines like the load, like whatever your load can power, whatever current is that is being delivered is whatever your load can power. Let me not just put it that way. But that voltage, so these are two different things. So this space is not just a space that you just come and then just be saying whatever you don't want, that you don't understand. You need to understand the physics. You need to understand the fundamentals. These are just even fundamentals. So you need to understand the physics. You need to understand the fundamentals, basic fundamentals. So you are saying that the current is low instead of you saying the voltage is low. So that is just one. Now he is now saying okay, I don't even know who did that. Maybe it's the electrician or the solar installer. But I think if you watch the video towards the end, I think it's the electrician. Because when the guy said the solar installer said it is because the current is low. That is why the inverter is not charging. So that they now installed a stabilizer. The installer stabilizer, we will call it voltage regulator. So the normal usual terms is stabilizer. That's the normal. I started growing up in Nigeria, right from my childhood, what people generally call it stabilizer, but the real term for those gadgets are voltage regulator. It regulates our voltage because we have irregularities of voltage in Nigeria, basically in Nigeria. So if you're having 120, 90, 150 thereabout voltage, the normal voltage that should power our appliances is 220 to 230. That's the best range. If you buy any gadget now, you will see it written on it. 220 to 230. Then you see the frequency, maybe 50 hours, 60 hours. You get my point now. The current also will be there. that is the current that particular gadget is going to draw from your energy source. You get it now? So it's going to be there. So which means for our basic appliances to work perfectly fine, then that means the voltage must be up to 220 to 230. So, but if NEPA or PACN now supplies us, or from grid supplies us anything below that, so it's voltage regulator that will now step it up. Sometimes, this voltage from grid could be higher, it could be lesser. So if it is lesser, the function of voltage regulator is to make it constant at that 220 to 230 range. If it is higher also, it is to also bring it down, make it constant at that range. You get the point now? So that's why we call them voltage regulator. So voltage regulator is what is referring as stabilizer. Now, what's the fault at that angle? Now, the fault at that angle is that you have a 10 kVA inverter, and because according to that video, he may measure the size of the inverter. You have a 10 kVA inverter, so which means that inverter is going to be powering a load of let's say 10,000 watts, or let's say if I will be using a power factor of, if I won't be following the manufacturer power factor, let's say for most manufacturer power factor for an hybrid system, but I don't think that system is an hybrid system, because I can say a solar charge controller there. So let's just say maybe a power factor of 0.8 or 0.9. So let's say the system is going to carry a maximum load of 9,000 watts. How can you now use a 5,000 watts voltage regulator to power a 10 kVA inverter system? Is I don't know, and you are now complaining. It can't even power. It can't even, because that system now is going to, while charging with grid, it's going to draw. There's a particular current that the manufacturer will have specified for it to draw from grid. That's one. Number two, it's going to bypass. So the load in your building is also going to be on it. So you must consider. So whenever I want to give specification for voltage regulator for clients, you must calculate the load of what the inverter is going to carry. One. Now, the current your inverter itself is going to draw from grid. Then it is these two that you're going to add together for you to get a normal kVA to use. So if I would recommend a kVA for that particular 10 kVA inverter, like a kVA of voltage regulator for that particular 10 kVA inverter, I would recommend like 15 kVA. I would recommend like a 15 kVA. So that would be perfect. So, but using a lesser, how do you want it? It can't work. How do you want it to work? It can't work. So most times clients are faulty. You have myopic idea, reasoning towards these things, and then job that is meant for a solar installer, you are calling an electrician to come and assess it. Check it now. To come and assess it. Has he done any solar installation before? Does he have any experience towards that? He's an electrician, for crying out loud. All what he understands is AC current, AC lines, connect live wire, neutrals, and all, switches, bulbs. That's what he understands. But when it comes to DC, does he understand this? Does he understand how an inverter system works? Does he understand how a solar system works? That particular system now, he is saying that the installer said 180 cannot charge. Those system 180 volts will still charge, 190 volts will still, but how do you do the settings? So there are a lot of things. That's why I said you need to reach out to someone with experience to always work on your system. Someone with experience to always work on your system. It's not just any other person. So let's just be careful out there. I've always been saying this. Let's just be careful out there. If what you want to do is electrical jobs, call your electrician, let it do it. If what you want to do is solar, call a solar technician, someone who is professional in it with experience. It's very, very important to fix it. Not you mixing it up. Something that a solar installer is meant to work on. You went to go and call an electrician. It is now doing one process. Now he's saying what does not even understand. Let me put it that way. He's saying a lot of things that he does not understand, and he will be confused. And someone that is confused will now do a job that is confused for you. You yourself, you are confused because that woman is confused. So please, let us be careful out there. Let's be guided. Let's know who and who we call to work on our systems. So there's another thing he made mention of again. He was saying because the transformer because the transformer is far away. That is why the voltage is low. How? If transformer is far away, has nothing to do with AC currents, movement of AC currents. In fact, study shows it's not just this is what we know, and from studies we also know that when you want to transfer energy at a far distance, the best mode to transfer such energy is at AC lines, not DC. And that is the reason why when we installers, we want to install solar system, and customer is now telling us that please, can my inverter be in this room and my battery is outside? We will say no. Why? Because once in DC lines, once distance is there, like once your cable is becoming longer, in fact longer, like let's say 2 meters, once your cable is becoming, the longer your cable in DC lines, the longer your cable, the loss you'll be having, huge loss when it comes to the, but at AC the loss is minimal. Not that we don't have loss, it's minimal. But at DC, when you have longer cables, the loss is higher, because at DC we are drawing enough current. So once the cable is shorter, our cable has minimal loss for the system to be able to draw the current it requires. So but for AC, because the voltage is higher, so you can move the current as far as possible, because the voltage is higher. But at lesser voltage, or in DC form now, at lesser voltage is usually recommended that the cable is shorter. So you see some clients will say, can I place my solar panel also place iron? So if we want to even do such, we make sure that whatever we are generating from our solar system is at higher voltage. It's still DC, but it's at higher voltage, because as the cable is, sometimes we can install, and then we have the total length of our cable from our solar where we mount our solar to where the inverter is going to be. It can be as far as 20 meters, 30 meters sometimes. So though for such system, if it is an hybrid system whereby we push in as high as above 300 volts, the loss is still used to be minimal. But if we're to be those days that we used to use external solar charge controller, that we do our connections maybe 2-3, I usually, if my distance is going to be very, very long, then I make sure that my thickness of my cable is higher than like 8 mm. It's higher than, like, I use 8 mm, 10 mm, depending on the total amount of current I want to generate for low PV controllers. So, but now that we now have hybrid system, which is high frequency and the high PV input controller inside of them, whereby the manufacturer will recommend, okay, at least 300 volts, some 400 volts, some 450 volts and above, or to 500. So the cable can still be, so the loss of current will still be minimal. So but for AC, that is why when you see they call it high tension. Why do you call it high tension? Because it's an AC line and it's coming from a far distance. It's called high tension because higher voltage is being transferred through that tension, through that lines. So, and it's an AC line. So whenever we want to transfer energy at a far distance, the best lines or best mode we can transfer is at AC, not at DC. So you now coming here now to now say that because the transformer is far away from the house, that is why we have a low as well now. So to me, probably maybe what I observe used to be the cause is when you have too much of house on a particular transformer, like too much of load, there'll be drop in voltage, there'll be drop in power. It's not about a distance, no. It's when you have too much of load, more than what the transformer itself can handle. That's when we have such. So please, let's know who we call to handle our things. Let's know who we call. Thank you.